You're listening to the AI Native Dev, brought to you by Tesla.
Hello everyone, welcome back to the AI Native Dev podcast. I am Guy Podjarny, and today I'm here with Itamar Friedman, who is the co-founder and CEO of Codium AI, who are probably one of the top leaders in the AI test generation world. We'll talk a lot about that, and they do a lot more than that. And has a very kind of varied and interesting background, notably has worked on verification in Mellanox and sales before, working on sort of chip verification and domains in which testing and making sure you get it right is a lot more serious or taken a lot more seriously than in software. Itamar, welcome onto the podcast. Thanks for joining us here.
Thank you for having me, and congrats on the new exciting podcast.
Definitely an opportunity to have conversations with interesting people like yourself. So I guess let's jump right into it. Tell us a little bit about what is AI test generation, and then later on we'll dig into what Codium does within that world. But what is AI test generation and why is it a topic now? How does it work?
Yeah. So first of all, testing or verifying that code works as expected is like a huge problem already. Specifically, I can tell you that I was in charge, at least 49% in charge of a bug in one of the corporates I worked in that cost the company $8 million. Just an example. And by the way, I think it's one of the biggest bottleneck in productivity. I think many of us experience that 50% of the work, the user sprints, the user tickets is related to bugs, etc. So it's already a problem. And testing is one way to try to overcome this problem, trying to reduce the amount of bugs that are introduced to the low quality code, etc. Mm-hmm. Having said that, I think testing it's just one word that describes a full field. There's many types of and classes of testing. I'll keep it short just to start with, like the unit testing, component testing, integration testing, system testing, end-to-end testing, etc. And I think in many of these, there are some inefficiencies and many, if not 100% of these testing types, there are inefficiencies that AI could help with. Some of them is actually in the planning of the test, even the strategizing how to test. Some of them is creating data for testing. Some is generating code or scripts for testing. Some are actually could be around AI selecting the right tests to run for a certain user story or a certain change in code. So AI could really boost and make it feasible to exploit testing, which we couldn't do before. I think everybody would want to do testing. I think everybody tries to use testing, and I think we didn't solve the problem of bad quality code or bugs in production. All of us experience, like I mentioned. So I think that AI and testing is about first identifying how to test your code, what is the right strategy, and then again applying AI to generating tests and maintaining those tests over time.
Yeah, those are really important distinctions. So we talk about AI test generation, and maybe I just leaned into hey, it writes a bunch of unit test code on it, but you make very good points, which is it's actually broader than that, and choosing what needs to be tested, where does it test. And I guess in all of these cases, the reason we say AI versus planning is because of the fluidity. Why do we need AI for this? In theory, software is fairly deterministic, right? It runs well. What is the unlock that AI brings us that we didn't have in more deterministic systems?
You mentioned my past experience working on chip verification, etc., and hardware verification. So I think when you think about a certain module and hardware, it's mostly described with a very clear specification with bits in, bits out, literally bytes in, bytes out. And you can even use formal verification, like mathematical proof, and in order to say, okay, this works as expected. But I think that with software, although it's like you mentioned, it's deterministic, I think the input output is human in, human out. The definition could be given a PRD or product requirement definitions or document from a product that might not be formally covering all the happy paths, edge cases, etc. Might actually be even vague of what it means. And the same goes, I can describe the output. So basically, the fact that software, in most cases, the interfaces and the outcome is supposed to serve people is human in, human out brings the opportunity to, and actually I think the must-have AI to cover those cases where you need to communicate with people. So I think that if you really try to cover all the options, like you're trying in hardware, covering all the options, or at least sufficient option to make sure that you don't have any bug, then you're having two problems doing that for software. One is that it's really inefficient. It could be like a nightly job for testing everything might not cover all the options that you want to cover, maybe differently than a certain module and hardware. And the second thing, it's not necessarily clear what are exactly all the options that you need to cover. And again, like AI could help you in both, like deciding what are those like the happy paths and edge cases that really worth testing, and then like actually helping to generate those tests, which is most people, like you mentioned, thinking about that. AI will help you generate tests, but what are a good test? What is a good test? And then eventually like also choosing efficiently. By the way, like a small story related to what we just talked about, like I heard a friend, like actually a client eventually saying that like he pushes his team to have 80% code coverage, and then one team reached 85% code coverage, and he was like really surprised. He went checking and he saw that there's no asserts, like basically tests were covering a lot of lines of code, but there weren't
But they
like
weren't asking any
anything.
questions in the process.
They, yeah, we really really check anything except that if it fails, like it crashes or not. Crashing it will check, but not if the outcome functionally wise is working as expected. I think that's something, for example, that will almost won't happen like in hardware verification, because the definition itself, input output, but could happen to teams in software. So that's
Great.
even the fact that software is deterministic, there's still a lot of test smells and know-how on how to do testing, and AI could actually help with that even.
Yeah. So interesting. So I think you mentioned maybe two big categories over here. One is this gap in the definition of what's right and what's not right. And so AI can help us deduce from the code what is it that you intended to do, maybe with the help. And we're going to talk a little bit about attended versus autonomous test generation. But it helps you understand that gap, which is it hasn't been stated precisely, unlike maybe in chips and their definition. What is it that is the correct behavior? And so it does it. And then the second is the kind of infinite realm or overly large realm of possibilities that software allows because of its flexibility, help us choose the paths that matter more and that we should focus on, or we should that maybe represent broader sequences. Is that right? Like we haven't gotten it all
Correct.
into a generation of, I guess all of this
Yeah.
is not yet necessarily Gen AI. This is just like AI. It might manifest as Gen AI, but it is still around insight. And here we
Correct.
get action.
Correct, because let's start with the second part, because basically you can't, it's not, most software is not just about a certain algorithm, where by the way hardware is like almost, you can almost like do a pseudocode of algorithm even for, let's say, like quality of service module in a NIC, like in a network like card, etc. It's almost like writing an algorithm. You can try to prove it. And while in many other type of software, like business logic of different kind, you can't like literally explicitly write some mathematics to, in many cases, to prove it. By the way, maybe in crypto, whereas there, I think, opportunity for AI, by the way, to introduce like more formal.
Because it's more formal, because
Yeah,
and it deals with things that are more
right. So it's not
deterministic.
like you can cover. It's not that trivial to analyze what is the minimal flows that you need to cover in order to promise with a pack. For a certain error, you're 99% sure that you covered everything. So definitely it's a big part. But and also about the generation part, I claim that actually generating like the eventual 10 lines of tests is not the hard part of about writing tests. I'm not saying that AI can help there. It definitely can help there. But actually, more important is what you want to test. What's the business logic? Let's describe it first in natural language description. What is you wanting to describe? And then you can use like another step in the flow of using AI to actually generate the code. But let me say it in different words. When we're talking about AI generating tests, roughly speaking, dividing into two. What do we want to test? And then generating that test. I'm claiming that generating that test is a challenge, but actually a harder part is describing in natural language description, what is that we're trying to test here? What are
Yeah.
you trying to test comes from what is the intent? What is this piece of software trying to do? You need to fetch this information from specification, from your documentation, from other pieces of code. And then how you want to test, what's the flow? You can still describe in natural language description. What is the data? Do I need to pull it from the database to bring the right, where is the right structure to put,
Right.
what is the right output? It's not yet the code, it's like a logic that you need to write. And then eventually you can convert it into code, which could still be challenging because you need the right imports and the right mocking and things like that. But both steps are very challenging. And I would claim that even the first is more challenging.
Yeah. So it sounds like it because it's a broader space, but there's maybe like a bit more margin of error here or flexibility. You can make maybe 7 decisions, while when you generate, there's an expectation of accuracy, right? Maybe let's dig into that. So we said when you talk about AI use in testing, it starts from understanding what it is that you want to do. So that's one. And then there's another layer that is still before the gen part, which is understanding what tests need to be generated to be able to verify that. There are an infinite set of possibilities. So what type of data, how does the system behave, what are the states, like all that information. And then subsequently, after all of that, you need to go off and generate a test. And that's the even newer field, because I guess AI, there have been a few kind of startups in the space trying to do the AI insight piece before. And I think Gen AI was the unlock around making it usable, right? Because if a system comes back to you and says, here, I figured out the 1,000 tests that you should write, you're going to say, thanks, but so long, I'm not going to do that.
Yeah.
And so I think that last piece of making it usable and actually being able to generate those tests is a big deal. No, that's at least the Gen AI unlock that allows companies like Codium AI to come in and be useful to a customer.
You know what? I'll make it interesting. I think I disagree. But I'm not doing it just to make it interesting. I'll give you an example. Let's be concrete. Let's say, for example, we talked about different types of testing. We're talking about, for example, we talk about end-to-end testing, and let's say that we want to do the end-to-end testing on the UI. Okay, I want us to be able to imagine. Think about an e-commerce. I don't want to say a name, but choose one of the e-commerce that you use. And now let's say that they're developing a new feature. With a click of a button, it automatically, let's think about 2024, automatically collects, you want to buy a certain item and they want to develop a new feature that with a click of a button, it collects your similar product that you bought and will bring you to buy something that is like this item, but already choosing the right color for you when displaying you this item to purchase on the buying page. So you could say, okay, maybe the hard part, if I take what you say, like maybe the hard part is actually generating the script that creates, I don't know, the Playwright, the Cypress, the whatever script that actually runs this kind of tests. But I claim that actually the harder part is to think about all the relevant flows that I want to test this feature. And think about the work of a QA tester. Like usually, like the more it goes lower to the code, like the unit testing, component testing, integration testing, you see the developers doing that work. And the more that you go to the end-to-end mobile and interface, you see more like a QA team or a QA automation team. By the way, I think that's going to shift left thanks to AI, but maybe not for another point. The first thing they do, and I think it's actually one of their hardest, is think about all the flows that needs to be checked. Eventually, I claim that when a bug is being eventually introduced to production, it's not because they didn't know how to write the code or they didn't have the time to write the code. They just forgot or didn't think about different flows they can come with. Oh, there was already one of these items in the carts and I didn't think about checking that option, etc. So I know there are solutions and I know there are products, but I actually claim that Gen AI, not just AI, has the opportunity here to reinvent and this field as well. For example, if you give a Gen AI the opportunity to crawl, this already exists before Gen AI, to crawl over different parts of your website and understand user behavior, and then generate flows, like invent flows, take the description from the product manager, and take all the experience of crawling the website prior to that and generate flows of testing, and then eventually also generate the test itself. So I'm claiming here that Gen AI is also going to be introduced in the first part of analyzing what you want to test and how you want to test. And I think it's very important.
I think I don't know if we're entirely in disagreement. I guess my sense is that this last part is not the hardest, but it is the grunt work that if you created 1,000 of those items, they will not get done. What we've seen at Sneak, for instance, was
Yeah.
if you came along and you said, here are 1,000 dependency updates that you need to do, and they are, very easy to do or relatively easy to do. Maybe there's a check around the system. If you don't you really need to hand it on a silver platter of here's the precise change that you need to do to mobilize people, and even go to the distinction, to the level of having that be automated and done for them. And it's not out of any ill will, and it's not because it's hard, but it's because it's tedious. It's because it's not a task that people want to do, and they definitely don't want to do it repeatedly. So I agree. And it's interesting maybe to have us define a bit the Gen AI piece. I don't know if that's the most useful thing for us to do. There is the Gen AI piece of the LLMs of understanding the system which we're using. So that is a new breed of AI, which is bucketed into Gen AI because it's a part of this sort of new breed of technology, but it's not generative in nature. It is more analytical still and doing it. And then you have the generative piece of, okay, now I'm actually creating a thing that would flow through them. But I think point taken, which is you have to understand the applications, you have to understand what was meant to be correct, you have to understand these sort of possible states and the flows within the system, you have to decide that. And then at the very kind of last step, you need to actually maybe write some code or Selenium scripts or whatever it is, some flow that would actually execute and interact with the application. And
Yeah,
then
by the way, I agree with you. I'll give you a concrete example. Like, I think it's an interesting one. So very shortly. So I agree with you. Like, in some cases, you know what you want to do, but actually executing that, Gen AI like actually enables that. And I'll give you a concrete example. We talked a lot about testing, but actually one of our second, or maybe I would say it's hard to say which one is our strength point at Codium AI, is code review and actually working around like increasing the quality of a pull request, almost another artificial eyeballs, and to describe a pull request and review it, etc. And here's an example that fits really well to what you described. In many cases, companies, they already know that they need to revamp a certain old, they want to modernize, if I call it like in a bit like Gartner word, they want to modernize a certain piece of their code. And they already, by the way, have symbolic or other type of tools that are not necessarily AI that tells them, give them a recipe on how to modernize a certain
like a Spring 2 to 3 or whatever it is,
yeah.
a new version of React.
Yeah, but then like they need a Gen AI to close some of the final changes. They need AI to make a final review. They need like the last mile of what you mentioned. I know what we want to do. We want to modernize, we want to revamp, we want to refactor this part. I know that's what I want to do, because what I claimed that AI could help you understand what to refactor, just an example of what we talked about. I know what I want to do, but actually taking the last mile on closing some additional piece of code, like a few lines of code that are not part of the recipe, and also giving a last review. You need AI, because I probably, in a big corporate, 10,000 developers, I probably need to do it so many times. I have to make it efficient for the reviewers to already have AI to review the first few things. So that's one of our use cases, and it fits to what you say. So I also agree with you. So I would say that's probably how the worlds divide. Like those use cases and challenges where it's actually hard to understand what actually want to test, what actually want to change. And then there's the part that actually, if you don't have the generative part to execute it, you can't actually efficiently
Provide
do it
the value on
at
it.
all. Yeah.
So maybe let's shift gears a little bit and talk indeed about the types of tests that you've mentioned in passing over there, because I think probably some of this, the importance of different aspects of this differ based on the types of tests. You can rattle them off, but what would you say are the primary categories of tests?
Yeah, I'm gonna talk a bit of sharing about different type of tests. I also like shake a bit the boat about their importance. I think there are times that people describe layers of testing with a triangle and sometimes as a diamond. I think originally the triangle was the most common shape that was accepted, which means that on the bottom you have the unit test, and then on top of that you're building like component tests. It's like a bit more than a unit, And then on top of that, you have, sorry, just for the sake of some of our fellows listener, although I guess 99% aware, unit test, it means like taking 4 lines of code, taking the smallest component, smallest element of a class, or even it could be even a sub function within a function or so, and trying to tie the test that will verify that this piece works as expected, isolated. The most isolated way would probably work the best for unit tests. They're fast. And then you have a bit on top of that, like component tests, usually like more, if you want like a rule of thumb, like a class, like where you can even describe like the shortest flow in your software. And while in
Unit tests tend to be very technical in nature. Component tests start to introduce some intent.
So there is some intent, but the intent is relatively still very technical, very like software, a certain very small piece of software. I very agree with you. I'm aligned with you. And then on top of that, you're starting to deal with microservices. It could be like traditionally 4 component, but it's just like a nice number. But it could be 2 component connected together. It could be 100 component connected together. But it's a microservice. It's now actually serving some business, full business logic. A full application could be one microservice to many as well, but it's one of them actually performing some service. And there, in these cases, usually you have integration tests, etc. There are more types, but just an example. That's the middle of the triangle. On top of that, you have system test and an end-to-end test, UI testing, etc. Where you actually, what you do is to try to test the entire application, the entire system, etc. There are more dimension and more an additional different type of coloring we can do here. I didn't talk about functional tests, non-functional, and things like that. But that's roughly the one way to look on the track. And I think some people would say, and I think it was more and more common in between 2010 to 2020, that actually the right way to look at it is that diamond, and most like value is in the integration test. And I think one of the reasons is because it's fucking hard to do unit testing because it's so rigorous. You need to go function by function. It's also hard to maintain it. But I claim that actually AI might change that a bit and make it easier to do unit testing and make it easier to maintain them. That maybe eventually like we will go back to that triangle is the way to look at it.
I think that division makes sense, but it always refers to just the unit size or the kind of the scope that you're testing. What about the notion of regression tests versus functional tests? I think we both put aside the non-functional tests, so there's just performance testing, security testing, a variety of those types of tests. I guess we're putting them out of scope for this conversation for a moment, but within, I always find it's important to talk about the source of truth, right? Because we talk about how AI helped you understand the intent, or what is it that you're even supposed to ask, and what is the correct answer, what is the correct behavior. All of those are very functional. Those are hard things, and they all revolve around the source of truth being the user's intent of some sort. But regression tests are different, right? Regression tests, the source of truth is really the previous version, and it's almost, you even want to preserve the bugs on it. I guess see them as the same. How do you delineate the two in concrete terms?
Yeah, I love this topic. Really, roughly speaking, I would like. I love your definition. Like, what's the source of truth? Well, really, roughly speaking, we can, when we're looking on that dimension, we can divide into two. One is that we want to test a new functionality, and it could be different subtype of tests there, and or we want to test that we're not breaking anything, and there could be a few types there. For example, regression test is like checking specific behaviors, like the functionalities and the integration level, unit test level, that what we knew that already should have worked, that we didn't break anything, like there's no regression. We could also, someone can put also smoke tests and others also in this category. Basically, I'm making some change in my code, and I just want to check that some simple, input provide me some simple output. By the way, in these tests, for example, smoke tests, etc., not necessarily checking behaviors intensively, but they check you didn't break something big, like the basic functionality is working. Yeah, so I think definitely it's worth considering that in general, and also when you're talking about AI. Why? Because when you're using AI and you're talking about more on the regression testing, then the code is like a very useful source of truth. You're saying this should work, how could I test that? But when you're talking about testing new code that you want to enter, actually your source of truth that you need to relate to is the natural language description. It could be like a structured one, like BDD, behavioral, like a business description of certain types. But I think that there's a lot AI like can really enjoy from the fact that code is a formal language that you actually compile. When you're talking about new code, that is the source of truth is the natural language description that might be formulated to some extent. It's still not formal language, and then it's like brings opportunity for mistakes. So definitely, when you're thinking of either building a product to generate tests with AI, or you're using AI to generate tests, you will see different even behaviors. Sorry, I want to say different behaviors, but even might be a different UX UI, right? Where does it reside? Like in the ID or in your Jira, but also the interface itself. One might look
Right.
like much more rigorous, and one might look like more a chat. Just an example.
Yeah. I think so. Maybe let's switch a little bit to talk about trusting AI generated tests. And it's a tricky topic. So we classified these types, or you classified these types of tests that grow in scope, from the unit to the component to the microservice to the integration. That clearly requires a more holistic understanding of the system and a knowledge of it. And then there's regression tests, and maybe there are smoke tests. Maybe they're a little bit easiest to just know what's failure. In all of those cases, you need to know what is correct. And the problem is that typically, to know whether it is correct or not, we use tests. So if you wrote the tests, then you can do all sorts of wild stuff behind the scenes. And eventually, you would generate something and you would test and you would see if it's correct. But if you're using AI, if you're rolling the dice to generate the tests in the first place, how do you know what to trust? What is the means of verification? The trust but verify. The verify is supposed to be with the tests. How would you define the way that people tackle that concern today? First of all, do you agree with this being a challenge? And then how should someone deal with trusting AI generated tests today?
Yeah, so first of all, I very agree with that, and immediately I can't not stop thinking about different memes and proverbs like, "Hey, who QAs the QA?" and saying like that. In the essence, this is a very
Someone needs to be the authority eventually of
yeah,
saying this is correct versus not.
yeah, and then specifically that's a very known like a term. Sorry, proverb like a problem. Like who QAs the QA? How do you trust that a QA actually QA'd everything, etc. So in essence, I agree with you. Like eventually you need the buck needs to stop somewhere, and the question is, does it stop in the AI or stop in the developers? It's one of the questions that they're raising here. But another, before I actually try to answer or more seriously relate to that, I want another aspect to say, like, food for thought. I think basically what we're talking right now, I can ask differently, like, how do we solve software? I think if it's almost the same question what you just asked me. How do we solve software? How do we like generate software that just works? I think it's almost the same question, because that's what testing is meant to do, and code review. And by the way, solving software, it's not just working code. It's performing, it's secured, it's maintainable, it's extendable, it's according to our company's best practices, it's according to our values of the company. I'm not kidding. I think
Yeah.
software development is actually related to also company's values, especially in the era of AI.
But
So
but but
yeah,
tests are like, I agree the tests are a necessary part of how do we solve software, but they're a part of it.
yeah,
Solving software also requires, better definition of what it is that is correct. Also implies thinking about the evolution of software and how does it change over time. Of course, it implies the actual writing or generation of the code and a variety of other aspects of software. I guess I'm like, we still have a lower resolution. A critical
yeah.
part of it is that whatever it is that you do, you need to be able to say, is it correct or not? But it doesn't, you can solve this and not yet solve software. You still
Yeah,
have other
totally.
things to do.
The point you said, that was my point. I'm saying eventually testing is a part of it. You want tests because you want to know that your software works. But I claim that the testing is our common way to do that, or that's what we're biased towards, because that's what we did for 20 years. but probably A, it's not the only way, and B, it's probably it's a sub problem. You want to check that your code works, but eventually, why do you want to check that your code works? Because you want to make sure that you're not harming your users and that you can move fast with confidence, etc. And there are other aspects that you need to consider if you want to do that. But anyway, now back to being
How
good.
do you trust it? How do you? And I guess we should also talk a little bit about maybe the sources of information for it. But for starters, like if I'm a user, I'm generating a test. Like,
Yeah.
how
No,
do I
to be
know it got it
concrete.
right? How does the system, how does the company or the organization know that those AI generated tests are trustworthy?
Great. So now to be concrete, because I think like the philosophy here is important because we want to understand why we're doing what we're doing. I'm going to answer you, I promise, in 2 points. But I do want to give you like an example of what I'm talking about. What about doing testless testing? What about like taking the specification that you wanted to have? For example, let's say that a certain technical product manager did describe really well what you want to achieve in the software, or a developer, but just like for the sake of example, a technical product manager described concisely, but actually precise with high accurate, elaborated specification. What about taking the code, and what you actually generate are not tests? You take the code and generate spec out of it, and then you do spec matching. So the process is generating spec that is the same format of the spec that was generating by the technical product manager, and then running a matching algorithm. Could be AI, could be Gen AI, we can talk about it, and tell you where's the mismatch. Hey, here's testing, but not the old way, but the new way that is enabled thanks to generative AI. So that's why it was important for me to go to the essence of why we're doing testing at all. We want to check that the software works according to our requirements, according to our best practices, and not just, okay, this piece of code passed the test. Okay, now let me be concrete. I think there are two things that we need to double click in order to test your testing. One is that usually in most cases, in order for an AI system or an assistant to generate meaningful tests, usually it's not performed by gathering a bit of context and doing one inference call. Usually there is a full flow, real product that actually works or works sufficiently well for you to useful for you. You're using a full flow. And by the way, I'd love to double click about later. Codium AI released a couple of these flows as open source, and we even reached state of the art code generation, doing better than professional competitors on coding competition, doing better than DeepMind, OpenAI, etc. And the concept that was different than other competitors like DeepMind and OpenAI, that we designed a flow. Okay, back to my point, to actually generate good tests is designing a flow. And then what you can do is surface, as a person that developing these tools, you can surface the decision that were made as part of this flow. And as a user, as a developer, you can review the process that was done on the path to generate this final test. And this gives you more confidence. You can gain confidence by reviewing the process that was done on the process. Let me give you an example. I'm going to give a simple example to make it short and clear. For example, as part of the process, the system might look for other mocking that is already implemented and trusted because they run as part of the CI/CD or whatever, and choose to use them as part of generating those tests. As a developer, if I see that this mock was not generated right now, it was actually taken from another piece of testing, another test suite that is, I know that I trust, and then I'll probably trust this new test that's based on that. And we like it or not, like I mentioned, testing is, if you do perfect testing, you know exactly what to cover, and you generate tests perfectly, this is solving software. So it's not easy. Okay, so it's not isn't a magical answer. Yes, I trust AI because it gave me a confidence number or because it did it 5 times correctly. No, it's the same process that you would do with a developer. You would see the syncing process, you would see the PR description, you would see and then you learn to trust this output. And that's number
So I
one.
think
And the second thing is that relating to the intent. If you see some connection, like you see the test and the AI system shows you this test was generated because here's the intent that I'm relating to, and here's how the implementation actually covers this intent, I think this is also will give you confidence. So these are I think the main 2 points that you need to look in when you're choosing a solution or as a developer to developing these systems.
I think those are useful kind of steps towards it. They include, first of all, they rely on attendant.
I'll use the opportunity to say that, of course, one more thing, that if the tests run, if it compiles, if it doesn't break anything. And by the way, this is what Meta released in their work, test LLM gen. Sorry, I have a blackout. I think that's how they call it. And we reproduced their work. They didn't release open source for it. We released a work called Cover Agent, Test Gen LLM, sorry, where their way to provide you as a developer confidence that the tests are good to create. They have more, but two parts: that the test builds and run, and that increase code coverage. Okay, but notice that this works only for a regression test. The fact that test builds and runs, doesn't break anything in your system, and actually increase coverage is only for a regression test. Okay, so there's more tactical things that you can do per test type. Regression unit test, you can do, for example, what Meta said. But in high level, It's what I said, showing you the process and showing you that you actually did something meaningful, like increasing code coverage, you increased the coverage of the intent, etc.
Yeah, and I think there are, once again, the different layers of it, right? The first part of it is agreeing on what needs to be tested. And you gave the example of the spec, but really that spec itself needs to be verified and back to an attended process. Someone needs to look at that and say it's correct. And then subsequently, you need to generate the test and see that it passed. And so code is a little bit better maybe than other Gen AI domains because you're able to run the code itself and see what has occurred. So at the very least that it's functional. I guess there's still a leap though about, okay, what you need to test, and you've generated a test that runs, but does this test actually confirm that the requirement that I've defined is correct? And then subsequently, you talked about the implementation piece of it and maybe delegating some of that trust by saying, hey, there's an already trusted mock, for instance. And so that's more like I've probably manually attended, verified that is correct. And therefore, I am building on top of that, and I'm able to trust that is as correct. And all of that are even ahead of the broader lens of, are these tests, like fine coverage is one measure of it, but are these the right tests to be running? So because you can define sort of an intent. I guess those are all compelling, and there's still a lot that is saved. And at the end of the day, if you have all of those, then you're able to develop with confidence, whether you're developing with AI or manually or whatever however you're doing it. But there's a lot of attended process over here, right? There's a lot of verification. Yeah. Yes, there's human errors, but there's also the goal here was to take the tedious parts away to be able to generate these things. We haven't even opened up the sort of the maintenance piece of it. What's the path to autonomy? If we're thinking a little bit further out and we say, this is the attended test generation process that happens today that saves you a lot of time, but still requires a lot of human attention, maybe with the exception of regression tests, which are making the leap of faith that the current way of running is correct. And so you can have this external source of truth that is scalable. It's the existing system. What's the path to more autonomy in the world of test generation?
Yeah. Okay. So let me first answer a question about autonomy, but actually it relates also to what we just talked in the previous question. So I think despite like amazing videos that we saw on X, Twitter, amazing demos that we see, I don't know, on stages, etc., practically most of this agents that are autonomously, like they're generating some software given a certain intent, this piece of software they're generating is very simple. I would even claim that most of these demos, you probably have a certain repo that you can find on GitHub that does very exactly that or very similar. So you can probably in 5 minutes do the same thing if you just
It's
copy
more
paste.
recall than the
And by the way, maybe it does transform it a bit to it's like almost like recall, like the right piece of code it was trained on, but also transforming into your specific request. So there is some magic, there is some good thing about it, but it's not close to, even like slightly close to generate anything useful for enterprise. Okay. At the same time, I claim that in 5 years, we will see an AI developer in enterprise. I'm calling that demo that we're seeing like an AI developer. Okay, sometimes some people call AI engineer, but that might be confusing. AI engineer is something with tweaking AI for. So an AI, autonomous AI developer, we will see something for that, but only in 3-5 years, the earliest. And here's how I think it's going to happen. I think we're going to see a first AI tools being integrated into different parts and already in the existing software development tool chain, processes, workflows. For example, our PR agent is connecting to your GitHub, GitLab, Bitbucket, etc. Sorry for the shameless plug here, but I really believe in what I'm saying. And it helps you already reviewing your code, verifying best practices, etc. And then, for example, you have another tool that connects your IDE, helps you do the unit testing, and then another tool connecting to your CI/CD and helping choosing the test, and then another AI tool connecting to your builds and helping you analyze the logs of failures. And once you have
these are
these,
all AI assistants, right? These are
right,
all, they're not
yeah,
autonomous.
I'll keep it right now in the AI assistant realm, although I think we can say that they could be also AI agents. But what I'm saying here, that even if they're agents, they're going to perform very small yet critical sub process in the overall workflow of software development. They might actually be agent. They might actually choose for you automatically which test to run. They might even analyze the build error and try to suggest you an option to fix it, build again, see that it passes, etc. So it might be agents, but we're going to have like many of these flows. Again, I'm referring to what we call flow engineering as the way to develop useful agents. And then suddenly, maybe sudden moment, maybe not. When we cover like a certain portion, 80%, 90%, I don't know, maybe it needs actually to be 95% of this sub processes, sub workflows with AI integrated in them. Suddenly, you can build an additional agent, an additional AI, automatic AI developer that will work with the, I don't know, technical product manager, will get and work with that manager on the intent, like formalizing, perfectionizing to some extent the intent. And then that agent would be able to generate that software because the guardrails agents, the angels, guarding angels, the other AI that worked really hard to integrate to the right databases, to the right frameworks, to the right best practices, to the right etc. Can have the feedback loop and perfectionize that. That's
Right.
one option. And another option is to rethink things.
So this is before we go to the other option, is
No,
this
I'm
one is
leaving
much
that to you.
more. This is much more. So I guess what you're describing here is, I don't want to say incremental, but it is about
Correct.
get better, help us as an industry, or let's as an industry get better at doing every one of these bits as they work today, like the code completion stuff and all that will generate code that better interprets intent. The code review will work better at spotting mistakes on it. The cover agent and its similar tools will help us test and identify whether a change has broken on it. Codium AI itself will help us build sort of functional tests around it, always in sort of an unattended fashion. And then analyze logs. And so we'll build all of that sort of journey of these different steps getting better and better. And then eventually, when all of those work together, then we have enough confidence to build something. And that's tricky because when you build a lot of these different pieces, if each of them works at a 95% accuracy, if you chain 10 of them, it's going to be broken half the time, right? Like whatever the multiples work over there. But it is, I guess it's the easiest one to imagine, right? Like let's just get better at each one of these steps. And then at some point, okay, all I've done is when I find myself every time just saying, yep, you're right. Yep, you're right. At some point, okay, just assume you're right and proceed. And I'll fall back if it seems like you were wrong this time. Am I describing the process like this path of evolution you talked about is the I don't know if it's a linear path, but it is the gradual path.
Yeah, I agree with you. And by the way, I also agree about the disadvantages of this approach. You know, we can claim that it's broken or not fully exploiting AI. So you're actually just like trying to do the best you can with what exists. And the other option is to rethink it. But it actually could be like a path that will not converge eventually. If there is some process, some sub process in the workflow that AI won't be able to overcome, and that's if that sub process cannot be overcome or cannot be automated with an agent, then you won't be able to pass this. You will still have some resistance to actually move to the autonomous AI developer. The advantage of this approach is that, look, it's probably really freaking hard for an enterprise to say, hey, we're throwing all the dozens of tools, if not more, that we're already using and the processes and the workflows and everything, and to change to something completely new. I'm not saying it didn't happen. I think we can find cases in the past, especially if that thing is like 10x, but it's hard. So that's a disadvantage that's the advantage of taking this approach. And by the way, one more reason, and it's tricky what I'm going to say, but I think we might a little bit exaggerating with what AI can do right now. Okay. And then maybe it's more feasible actually to take like small parts and in the current workflows and trying to improve that. At the same time,
and get real value. It's
right.
not the fact that it doesn't jump to autonomous doesn't make it not valuable, not by a long shot. Like these tools, Codium AI today, the code completion, like they are massively valuable today. They make people more productive. So they're very valuable in their own right, which is another advantage of the gradual path, which is you're already going to be doing it because there's immediate benefits to be had.
Yeah. At the same time, again, it might actually maybe the path to autonomous like needs to be like we need to rethink. And I can think about a few points that maybe
so let's talk about that. Let's maybe close off the podcast the other way around and say, okay, let's say we didn't increment our way to it, but we managed to throw the thing away and reimagine the software development process. And maybe let's still put a certain lens on the sort of the testing or verification aspect of it. But how would we do this better if we were to reimagine the process?
Yeah. So I think like you see my repeating notion here that we want testing, whether, especially if it's not regression, if we want to test new code, is I think it's all about the intent. Yes, I agree with you. Like what we talked, if we close the loop with what we talked about half an hour ago, that eventually Gen AI gives you the opportunity to do the last mile of I know what I want to test, and then it's actually like I have 1,000 of these, and I couldn't do that without Gen AI. But I still think that in most cases, actually, one of the hardest problem is to start with having the right and having a good intent, having a testable intent, having an intent, a spec that is already anchored in and with the current code. I'm developing new code, and my new specification is already anchored while I'm writing it, while I'm inventing it, while I'm creating a new user story, etc. It's already anchored in the language, in the way I describe it as, for example, a technical product manager to my code. So to rethink everything, the software development, also with the spectrum when focusing on testing and verification, it's a lot about the intent. Working with AI and reinventing how we as the R&D and product as a whole, thinking about how do we write our specification, how do we define our intent, how to exploit AI to already create a PRD or a spec, a technical spec or a product spec that could be more easily already to start with exploit AI to then generate the code and generate the test and generate the review and etc. If we rethink that part, then we would make it easier for AI then also to complete the code and complete the testing and complete the verification.
Yeah, and I think clearly I'm aligned, right? When we talk about AI native software development, we think about sort of spec-centric software development and how that centers it. Today, like you mentioned at various points, this notion of looking at the code and first understanding, maybe it comes from that PRD from someone who's written it, maybe it comes from the understanding of the code, and create an understanding, create a spec of sorts in the brain of Codium AI, somewhere in the process that says, this is how it works. But in today's software development process, the tests are that specification, right? There is no interim, there's no at least commonly used interim representation of those intents. They come hand in hand with the tests of the implementation as well.
Good for me, because that's related to something I wanted to talk about previously, and then it connects. Um, okay, there's no one way to test things. Like we said, ideally tests are meant to verify that the intent is actually being implemented. But actually, because there's no like formal way to do that in software, and in most cases, like unless it's like an algorithm or so that can prove mathematically, there's a few ways to do that. And different companies and different teams have opinions about it. So a lot about like generating tests and giving confidence that these tests are good ones is actually generating those tests according to the best practices that were given by the developers. So one of the things that for example is enabled in Codium AI, PR agent, and as an example, is that a team can give a markdown. Hey, here's how we would like the testing style to be in this repo, and this is how the testing style would like to be in that repo. Once you make testing, once you enable an AI dev tool to generate tests, work according to your best practices, working according to your test style, and then if that tool works well enough to quite easily, I'm not saying with the click of a button, but much 10x 100 easier than it was before to generate tests, then yes, tests could be your source of truth for the spec. Some CTOs that I talked to told me that their preferred documentation is actually working tests. So that's
Yeah,
aligned with what you said, like
right.
documentation as
And
spec.
there's a whole TDD world that really talks
Yeah,
about sort of tests
yeah.
being at the
So
center of the universe.
I agree with you. But like I mentioned, again, it's not magic. It's not like just, okay, AI will generate those tests and here's my new spec. No, we need to build a tool that generates those tests according to a specific style that your dev team and even your product managers, technical one, would consider as a spec. And then if we can make those test executable specs which are tests in your style, in your and easy for you, then we can actually rethink specs, executable specs.
Yeah, yeah. No, well, clearly aligning our view over there. And it'll be interesting. There's a lot to probably unravel that we might do in sort of future conversations on the evolution of those specs and how do they
Yeah,
change and how do they relate to data. Itamar, this has been fascinating. Thanks a lot for coming on, for sharing. I do encourage everybody to check out. We didn't talk too much about Codium AI's products
good.
on it, but there's a bunch of good free tools out there in sort of
Yeah,
cover agent, PR agents. And I guess actually most of the solutions that you have, Itamar, have a free tier of a way for people to experiment, to try out with, and then expand into a premium version, right?
correct. Our ID agent, which we call Codiumate, our Git agent, which we call PR agent, like our Git plugin, our ID plugin, our CLI plugin, or they have the Codiumate PR agent, cover agent names. That they're all free, and some of them are even open source. We have just one component that we didn't yet find a way on how to move it towards the free, which is our full code base analysis.
Right.
Like you can give the Codium AI platform, you can provide it like 10,000 repos, and we run like different analysis. And we do want to shift some part of it into the free offering, but it's still on the work.
Yeah, that's okay. You have to pay the bills and stuff.
Yeah,
So I'd encourage everybody to try it out and tiptoe their way into this brave new world of AI generated tests with its great promise and some complexities and some adaptations we probably need to do as humans. Itamar, thanks for coming in to share all this insight and knowledge with us.
thank you, Guy. It was a pleasure. I'm happy we talked mostly about interesting stuff. Codium AI is one tool of, I think, exciting, one set of tool, one platform of the exciting, intelligent coding system that I think we're going to see in the future. And then thinking about how we as developer imagine that, I think that's what's exciting. And then the tools are here to just enable that.
Awesome. And thanks everybody for tuning in, and I hope you join us for the next one.
Okay.
Thanks for tuning in. Join us next time on the AI Native Dev, brought to you by Tesla.